Hey everybody, today we're going to be solving problem 438, final anagrams in a string. Given two strings, S and P, return an array of all the start indices of P's anagrams, and S, you may return the answer in any order. So, given this S, we have the answer 0 and 6, because at index 0 we have CBA, and at index 6 we have BAC, which are anagrams of P. Same thing with this one as well. We have 0, 1, and then 2 to get AB. Our constraints are S and P are not going to be empty strings, and S and P consists of lowercase English letters. This is a problem that can be solved using sliding window because we are only constrained to basically windows of size of length P. Okay, so what about any other constraints? I would ask the interviewer here. Do we need to check if S is always going to be greater length than P? Because we can't make an anagram from S if it's shorter than P, right? So that's probably one check we should probably go ahead and do first. Um, Also, when we're checking through all of this, if we're checking each window and we're creating basically a counter for each one of this, that's gonna be the time efficiency of big O, big O of length S times P, because we have to uh, keep checking every single count using the counter function, or we could create our own counter function, s times p, which is the length of p. Now there is a faster way we can do this, right? If we're going to be iterating through each of these windows, we are basically only uh, adding a new character to the right, and then we're decrementing the character from the left from our account, and then we're checking if it's still equal to the same count as P, right? Okay, so that would actually help reduce our time complexity down to S of just big O of S. Um, so let's go ahead and start working on this code here. Let's go ahead and first do a check to see for our length S and length P, which is going to be equal to length S and length P. Now we're going to do our first check here. Check uh, the lengths for valid anagrams. Anagrams. If length S is less than length P, then we can return an empty list. Okay, now that we have this, we can go ahead and create a helper function to get the counts, which is get counts, and given a string s, we're going to return a dictionary. So let's get the count, which starts off as a hash table, and then for character in s, we're going to say count at this character is going to be equal to 1 plus count C. However, in Python, this actually will throw an error because if C does not exist already in the count in our dictionary, it will return an error. So what we can use instead is count get, where we check for that character if it exists. If not, the second parameter is going to be the default, which is going to be 0 in this case. And then we could just return our count dictionary. So now that we have defined this, we can go ahead and create. our first starting. Let's go ahead and create a count S and a count P. Now the count S, we're gonna go ahead and first get a head start and start off with our window with C and B, and then in our loop, as we loop through the whole string S, we're gonna start from the range of this character because we're gonna add that new character, and then we're gonna check to see if this window right here is gonna be equal to the count P, and then we're going to go ahead and after we've checked that, we're going to decrement this, and that's going to be our while loop. We're going to decrement the left character from our count S, and then it's going to start all over again and go ahead and start at this new character. So to do this, let's go ahead and say get count, and we're gonna get S, and we're gonna get only the first two characters, which is gonna be length of P -1, because at index 3 -1 is this one, and Python this basically will say what this is right here is basically saying S of length P -1, which is 3 -1. This turns out into a 2. It's only going to get the first two characters. So um, everything basically, here's the two index right here, is going to grab only these two. So in this case, what count S would look like is going to be like this. C1 and then B1. Okay, now that I've explained that, we're going to go ahead and create our count for our P. We can just pass in the whole string right there. Okay, now that we have the counts for that, let's go ahead and create our left and right pointers. Left, it's gonna go ahead and start off at 0, and then let's go ahead and do right as well. So right now our right is going to, left is going to start at 0, then our right is going to start at this new character right here, which is length of P -1. So let's go ahead and say while right, actually, since we're iterating through, let's go ahead and do this. For right in range of, oh, you know what? Actually, if we're gonna just go ahead and do that, then I don't have to initialize it here. Let's just go ahead and initialize it in here, and then we'll move that over here. Length of P -1, and then we'll go all the way to the end of here. Okay. Mm-hmm. Okay. So let's go ahead and do this. We're going to do s count. Count as count as start up with making this a little bit more clear. We're going to say our new character is going to be equal to our s at right. So right now we are basically at a right here. And then we're going to say count as new char equals 1 plus count s dot get at new char. If it's not there, return 0. So right here we are adding new char from right. Okay. Now that we've added that, we have this whole window right here, and now we can check if the counts are the same. Check this. If count s is equal to count p, then we're gonna append this to our result. Oops, I forgot to initialize the result. Result equals, and I could say result dot append left. All right, now that I've checked the counts, now we can go ahead and remove s left. Okay, so let's go ahead and do that. Left char equals s left. Then we're gonna say count s left char, and I think we could do this. We could do minus equals 1. And then we could just check it here. If count s at left char is equal to 0, then we can just go ahead and delete that left char. And let's go ahead and increment our left pointer here as well. And then it will just keep iterating on to the right at the new one right here once we get to E. Okay, so now that we've removed that, we've gone through all the way to the end of line S. Right here, S is gonna be at the end here and it's gonna check. Okay, now that we checked that, I think from here we can just return. Well, eventually we will return our results, right? So let's go ahead and see. This should be the answer. Let's see if this works. Okay, looks like it works. Okay, looks good.